All right, so get out the lesson 3-2 logarithms note sheet that we started the previous day. All right, we are going to turn to the second page and talk about these graphs. So one thing that I want you guys to know is that exponential and logarithmic functions are inverses of each other. Exponential and logarithmic functions are inverses. All right, so we spent Monday or Tuesday graphing exponential. And so exponential functions, if you guys remember, looked like this. They had horizontal asymptote and then got bigger and bigger and bigger. All right, so back from several units ago, we learned about inverses, and the graphs of inverses are the reflection over the line y equals x. So y equals x is that dashed line right there. So if we reflect that green graph over that line, it's going to give you something that looks like this blue graph. All right. So this one is logarithmic. This one is exponential. All right. And so logarithmic graphs are going to have vertical asymptotes. And the domain is going to be restricted instead of the range. All right. So let's just talk about some reflections real quick, and then we'll talk about the parts. All right, so the parent function for logarithms, we'll just say y equals log base b of x. All right, so it's going to look something like this. All right, so the argument is of the graph or of the expression is this x right here. The base obviously is what you think is, we've been talking about it, and then y is the exponent. So if we are wanting to find the domain of these functions, we're going to take whatever that argument is, and we're going to say that it's greater than 0. All right, and then the vertical asymptote is found by taking whatever that argument is and saying that it's equal to 0. And the x-intercept, you make y 0 and then solve for x. All right, and then we are going to have some reflections. So let's talk about what happens on these reflections. So if I wanted the graph of y equals negative log base b of x, all right, if you guys remember from transformations, a negative on the outside is an x-axis reflection. So we'll take that blue one that we just graphed and reflect it on the x-axis, so it would look like this, something like that. Still has that same vertical asymptote, just flipped upside down. All right, and then whenever there's a negative on the inside, so we have y equals log base b of negative x, that's going to be a y-axis reflection. We used to call that the yin side because it's the y. Oops. All right, and then it takes that blue one and reflects it on the y, so it's just going to be pointing in the other direction. All right, so that's just something to keep in mind. as we're doing these graphs. All right, so we're going to do a couple of examples for example 7, and we're going to find the domain, the vertical asymptote, the x-intercept, and then we're going to do just like a little sketch. We just need to know the basic shape, and then we can do the sketch. Okay, so for A, and on all of these logarithmic functions, when we want to find the domain, you take what you're taking the logarithm of. It's the argument. It's this x plus 2. And you're going to say that that is greater than 0. Now, we do need to take it one step further where we actually solve it for x by subtracting 2. So x is greater than negative 2. All right, and then logarithmic functions have vertical asymptotes. And once you get the domain, the vertical asymptote is easy. You just change that greater than or less than or whatever it is to an equal sign, and that's your vertical asymptote. All right, and then our x-intercept, we go ahead and set it equal to 0 and make y 0. So log base 2 of x plus 2 equals 0. Now, right now, the only way we know how to kind of work with these logarithms is to do the loop, is to rewrite it in exponential form. So I'm going to loop around. So it would be 2 to the 0 equals x plus 2. So it's the same thing we did yesterday, just a little more complicated. All right, and then 2 to the 0 is just 1. And then whenever I solve that for x by subtracting 2, I'm going to get negative 1. So that's going to make our x-intercept the point negative 1, 0. All right, and this graph doesn't have any kind of reflection. So if there was a reflection, you would have a negative in front of the log or a negative inside close to the x, and we don't. So what we'll do is just graph the vertical asymptote at x equals negative 2. And don't forget, vertical asymptotes are graphed by doing dashed vertical lines. All right, then we'll graph the x-intercept. So our x-intercept is the point negative 1, 0, so right here. And then we just draw the shape of a logarithmic graph. So we're close to the asymptote. We're going to go through that point and then curve up in the shape of a logarithmic graph. And that's all I'm going to have you guys do. I'm not going to worry about you finding other points. Just get that basic shape down. All right, so let's look at another one. So for B, same direction. So we'll start off with the domain. When we do the domain, remember we take the argument, so this whatever we're taking the logarithm of, and say that that's greater than 0, so x is greater than 1. Right, then for the vertical asymptote, remember we just go back and make that greater than or equal to. All right, and then for our x-intercept, we're going to take our equation, our function, and we're going to set it equal to equal to 0. Okay, and then we'll subtract that 1. And we'll go ahead and do that loop. So it becomes 2 to the negative 1 is equal to x minus 1. 2 to the negative 1 is 1/2. All right, and then I'll add that 1. So 1/2 and 1 is going to be about 1.5, not about 1.5. Okay, so our x-intercept is at 1.5, 0. So I'm going to go over to my graph. I'm going to graph my vertical asymptote. All right, then I'll graph my x-intercept. And then I'll just be close to the vertical asymptote, curve through that point. Okay. And then for example 8, the students in a math class were given an exam and then retested monthly with an equivalent exam. The average scores for this test are given by the human memory model. So that is the human memory model. It involves a logarithm without a base, so it's a common log. And T is the time in months since they took the test. All right. So this would be like, it's been about 3 months, I guess, since I gave you your first test in here. So if I was to give you that test again, like see how well you would do on it the second time when we haven't reviewed or anything. So that's what this human memory model is about. All right, so A asks, what's the average score on the original test? So this is a calculator problem. And so what we would do is on the calculator, there's different things we can do. I am just going to put it in to y equals, and just get my stuff I need from the table. So it's going to be 78 minus, and then if we want the log button is right beside the 7. And that's common log, like I said, because it's log without a base. And then in the parentheses, we would put in x plus 1. Okay. And then we can go to the table. And so the first question is, what was the average score on the original exam? So that's when t is 0. So it looks like when t is 0, that human memory model is 78. All right. And then over time, you're going to forget things, so you won't do as well on it 3 months later. So let's see what it is. When t is 3, it's 67.765. Or we'll just say 68. And then after 11 months, it looks like it's about 60. All right. So that's an application of logarithms is using the human memory model. All right. So I don't know if you noticed, I've been super distracted teaching this lesson. My daughter tested positive for COVID. I just found out about it a few minutes ago, and I was around her this weekend, and she wasn't feeling great. So I'm quarantined, but luckily, I'll be back. As long as I don't catch it, I'll be back whenever school comes back in session. It's just going to make Thanksgiving super sucky, but that's okay. Hopefully we'll all stay healthy and she'll get over it quickly. But anyway, here's your assignment. This number 81 is a calculator question, but it's the only one I want you to use a calculator with. All right, and the substitute should also give you your Friday assignment for tomorrow. So no video tomorrow, just going to work on a worksheet. So I should see you guys hopefully right when we get back to school, which is the 30th. You all have a great Thanksgiving and stay healthy, please.